So, yeah. So I wanted to go over this real quickly. This is a NAM, right? The NAM 3 kilometer, right? And you would look at this saying, "Are we really gonna get this much sleet here?" All right. I would say in this case, yes. Less trees and rain and more sleet, given the depth of the cold air at the surface, right? So I took a sounding here from the this area, right? And now we're getting into the weeds here, but I wanted to show this and I wanted to bring up my pen here, analyze this a little bit, okay? If you'll permit me, right? So if you don't want to listen to this, you can certainly go to another part of the video, but interesting photograph here. You see this here? It's incredible. Like if we had I wouldn't be surprised if we get thunder sleet with the amount of forcing and things going on. We'll talk about that as well. But the photograph, you would think you get a tornado or something, but you see down here, not likely, right? Although you still have some cape here, right? So I don't know. But and you see the lapse rate at 36 kilometers, um, pretty steep. But so getting out of the context here, but there's a deep melt layer here, right, between 3 kilometer and about 1 kilometer here, right? So almost 10 Celsius. Is it overdone by the NAM? Probably a little bit, but that's way more than enough to melt the snowflake totally, right? But because the freezing layer is so deep here, it's almost I don't know, 4,000 feet at least, almost a mile, going up about 850 millibar. So in this case, it can refreeze. So there's two different things here that can happen with a snowflake. A shallow layer aloft could partially melt it. It remains like slush and then refreezes with not really deep temperatures, cold temperatures at the surface, although below freezing, right? In this case, because it's so cold at the surface and so deep, the freeze layer is so deep, it refreezes here. So I would say that we could be in for some heavy sleet in this area. So based on this sounding, I would tend to agree with what the model says. So yeah, I mean, interesting when we look at it, right? So we compare it to the GFS um, output here. The GFS has a different thermal profile for the same area, right? On the same time frame. And what's interesting about this is, in understanding it, is the GFS has a warm nose, but it's not nearly as deep, or it maybe gets to about, it doesn't even get close to zero, right? Go back to the NAM, totally different thermal profile. So, but the surface, uh, it's, see this here. I'm trying to look at the temperatures here. If this is in Celsius or what. Pretty sure this is Celsius. Yeah, it has to be. So -10 Celsius, right? So, and 10 Celsius here. So 0 Celsius, 32, right? And we go here. It's showing it like -10, the surface. So the GFS is showing it like colder at the surface too. So quite a lot of differences in the model here. So interesting. 06Z. All right. So I want to make sure I was comparing apples to apples here. So you can see what the difference is. Quite a big difference between GFS and the NAM. So and the GFS doesn't have as high resolution. So Um, that may be one of the reasons it tend to smooth out things on the atmosphere. Although it's hard to explain the temperature, surface temperature differences here. The NAM may be overdoing the warm air advection, but I don't know if it's overdoing it that much. So anyway, going back to this, quite impressive sleet totals here. And snow. We're gonna have 2 different rounds of snow here, right? We move through time with this. You can see where the heaviest snow will be into central Oklahoma here, and right along this boundary into we're gonna have sleet, heavy sleet potentially. And again, um, this is Sunday, another round moving through. The system finally kicks out, moves to the east, right? Um, and then cold air really dies down here to the south. So let's zoom out for a minute and go. Let's see if I can get further to the east here. All right. So we're going to the east here. I think it portrays the CAD wedge pretty well here. All right. So let's take a sounding from right here. Takes a minute to come up, guys, so bear with me with this. All right. So yeah. Move this over to winter. It keeps generating severe sounding, but gotta let this come up. Excuse me. So you can see the thermal profile here. A very strong warm nose aloft. Now this may be overdone some as well, but you know, 0 degrees Celsius, dew point, and just barely above freezing here, right? So move back. Now you move a little further to the north here. Letting this sounding come up. This takes a minute. Thermal profile is different here, right? Changes to winter. I gotta make sure that it does this as I analyze this winter to start with, right? Um, so very deep warm nose and shallow air at the surface, freezing rain. All right, so let's move further to the north here, up into say North Georgia. Move through time with this a little bit. How about up here into South Carolina? One more sounding here, and then I'll stop chattering here. So, um, winter. All right. Yeah. So freezing rain still. Although I would say this is marginal. This was a little deeper cold air at the surface, right? We would get sleet. So this is a borderline. Look at that photograph. low level. It's just it's crazy looking at that. I, you looked at that, you would be like, man, we're gonna get severe weather. So, I'm gonna take one more sounding here because this model right here is showing sleet, and I'm clicking on this area, then the sounding says something different. So, um, interesting to look at this. Yeah, even on this one, freezing rain. So I think this is on the edge here, depending on how deep this cold layer is. So we go further north here, where the cold layer is deeper, right? Let's go up to North Carolina one more time. Forgive me here. Go to winter, generate new sounding. Yeah, so this is why it's sleek, guys. See the dendritic growth layer is really large. From -12 to -17C. All right, so 7 2700 and 1990. Yeah, it's weird. But anyway, this yellow line here, I don't, it's weird the way this is plotted. But anyway, you can see how deep the cold area here, how cold it is at the surface. So um, and it doesn't really melt that much aloft either. So probably slush at this point. So interesting. A lot of interesting stuff here. Hope you don't mind me going over this stuff in detail. All right, so I hope y'all got something out of this here.